Okay, for this one, it's 15.1.2, number 17, and we're starting to look at the applied problems. And with these, we tend to have to work pretty hard to find our limits of integration. The function itself tends to be pretty easy, but it's the limit of integration that are a problem. They tell us to do it above this region, and this region, if I go ahead and graph it, there's x, there's y. It basically, x goes from -1 to 1, and y goes from 0 to a parabola 1 minus x squared, which is a parabola that goes through 1 on the y-axis and opens downward. So this becomes the shape in the plane that we want to find the volume above. So if I draw a little rectangle, this is going to kind of represent our little integrand pieces that we're going to integrate. So x is just going to go from -1 to 1. That'll create all the rectangles. The tricky part is the y height. I want to integrate from 0 on y, and the upper limit of it is actually going to be what the x value is on that parabola. So our y integrals are going to go from 0 to 1 minus x squared, and our x are going to go from -1 to 1. So let's build those. It's -1 to 1. And then the integral for the y is 0 to 1 minus x squared. We're integrating the function 1 minus y dy dx. Okay, so let's do the inner one first. The inner one's going to be the integral from 0 to 1 minus x squared of 1 minus y dy. And of course the integral of this is easy. It's y minus 1/2 y squared. And that's evaluated between 0 and 1 minus x squared. So we've got some substituting to do. When all is said and done, we're going to end up with 1/2 times 1 minus x to the 4th. And that's the result of plugging in that upper limit and then doing all the algebra necessary to simplify. That then becomes the argument for the outer integrals. So the outer integral is -1 to 1 of 1/2, I can actually move the 1/2 outside, of 1 minus x to the 4th, and that's dx. So that's going to turn out just to be 1/2 of x minus x to the 5th over 5, and that's evaluated between -1 and 1. And once I plug in the upper and lower limits and do all the simplification, I get 4/5. So the area of this unusual region that basically is defined, upper bound is this plane, z equals 1 minus y, and the bottom of it is defined by this parabola within the xy plane. So it's a parabolic shaped wedge that has an angled top, and this is its volume.